So let's look at the interaction and effect modification. So I told you that when a particular predictor, the coefficient is dependent on the level of another predictor, then we can say that there's an interaction. So the models we did earlier on, there was no interaction, like this particular simple model, there's actually no interaction. But for a model with interaction, this is how you can signify interaction using the asterisk sign. So between smoke and race. So when you put this asterisk, it's going to take into account smoke, race, and also the interaction between smoke and race. So let's run it now. If we run it now, and we call summary model no interaction, then summary model interaction, you can see the two models. So this is the first model, no interaction. You can see there is no interaction here. So just like what we did earlier on, and you can see we have an interaction in this particular one. So now I'm just going to be explaining the interaction component, since we already know how to explain this other component. Now, what this interaction component means that what someone that smokes and also from a black race, then their birth weight is likely going to increase by 251.4 compared to someone that is not a smoker and also from the white race. This one also says that someone that smoke and also from an other races, and their birth weight is likely to increase by 543.3 compared to the person that what does not smoke and also from the white race. So this is what this particular interaction term means. So you can see, though we have the interaction time is not actually significant. You can see that not actually, it's only this particular one for those that smoke and from other races that is actually significant when compared to 0.05. So this is how the interaction actually works. So we want to test using the ANOVA method if our interaction is actually significant. So you can see that what the interaction is not actually significant if you look at the p-value. So the p-value here, the interaction is not significant because if you look at it, you see that it's only that of smoker and race order that was significant. So we want to just visualize the interaction now. So what we're going to do first is going to calculate predicted values. We're going to use expand.grid. So we have our smoking levels and we have our race levels. So we're going to create a predicting data. We have the various levels of smoking. We have the various levels of race. For non-smoker, we have white, smoker, white, non-smoker, black, non-smoker, order, smoker, order. Now, we're now going to get our predicted birth weight. We're going to run this. So we're going to create a predicted birth weight based on our new model that has interaction. Then we use ggplot to create an interaction plot. So this is ggplot. We're going to give our predicted data, and our x variable is going to be race. Our y-axis is going to be predicted birth weight. I'm going to give it a color using the smoking category, and the group is also going to be the smoking category. So we're just going to run a jump point, jump line, and also we give our various axis titles. So I'm just going to run this particular code. So this is the interaction, smoking and race on birth weight. So just the simplest thing for you to know whether there's an interaction or not is that if these lines are parallel, they don't meet, or they are not about to meet, then we can say there is no interaction. But if these lines are not parallel, you can see they are almost trying to meet in this place, then you can say there is an interaction. So we also have another example, which is continuous and continuous interaction, which is between age and LWT, mother's weight. Also going to run these two also. Look at the interaction. So you can see in terms of the interaction, there is no significance. So the interaction is not significant. So this is just the same thing we did in previous example too also. We're just going to run the whole of this code to visualize it. Let's see what we have here. So though we can see some interaction because the lines are not actually parallel, but this particular interaction that I seen is not actually significant by the time we look at the test statistics, the p-value we got earlier on.